Officer at Grey Hat, also GT alumni. He was a former pen tester at Bishop Fox as well. Got a ton of experience. He comes out here and gives us a ton of talks. So just give him a round of applause.
Cool. All right. Are we good to get this recording? Recording? We're good? Yeah. Sweet. All right. What's going on, everybody? My name's Grayson. I used to be the president of Grey Hat a few years ago and have tried to stay involved as much as I can ever since. Real quick to what Sid was saying, the whole admin position, if this is something that you just listened to and was like, yeah, that's not really for me, I think you should reconsider. Really, the only reason that I'm up here standing in front of you today is because I took the initiative and did it. The only reason I got a job pen testing was because I was the president. The only reason I've done a lot of things since then is because I got actively involved in this group. If you want to break into things professionally for a living, first off, that's awesome. Second off, it's super enjoyable. Third off, the number one way that you can prepare yourself for that, participate in CTFs, do various things with this organization, but the best way is to be one of the admins, to be one of the ones that's pushing this forward. There's really no big enterprise located in Atlanta that doesn't know the Grey Hat name. If you're one of the admins here, if they're hiring for security positions, you will immediately make it to the top of that resume stack. It really does shine on your resume. So yeah, please do it, give back. All the folks here that are admins that are putting this together, the food that you get, the presentations that are coming in, you have people that are working really hard to make that happen. None of this happens without their effort, and when they're gone, if nobody else takes up that slack, then this fails. So please consider it. So today, I'm going to be giving a talk that I've given a number of times before, and it's going to be on something called Burp Suite. Who here knows what Burp Suite is? Okay. And who here has used Burp Suite? Okay, a few people, awesome. And then by a show of hands, who here is a first year? Second year? Third year? Fourth? 4+. Yeah, that's the way we do it. Cool. So I'm going to try and aim this talk at if you've never even worked with web applications before, you've never built web applications before, you've never taken a dive in here, this is for you. That's kind of the level that we're starting at, and hopefully I'll bring you to a point that, after we do this, you can run Burp Suite on your own, and you can go do this against vulnerable VMs in your own time. So hopefully you'll be able to leave this talk with the ability to practice these skills on your own. That being said, and I preface pretty much every single one of my talks with this, do not do what I'm about to show you to anything that you do not own and that you do not have explicit permission to do these activities on. Because if you do, you're breaking laws that not only is that a problem at the state and federal level, but if any of the admins or any of the faculty members associated with this organization find you out, they will be the first ones to report you. They will be the first ones to tell the police what you're doing. This is not a joke. One of the things that I will show you is how you can do this responsibly. It's resources where you can go and do these activities. And really, if you want to start doing this against production systems, like stuff that other organizations own, there's ways that you can do that legally as well. So I'll finish the talk by talking about some of those alternatives. This application right here is my buddy Joe's basically made to be vulnerable web application. Joe is an incredible hacker, incredible software developer. If you ever get to the point that you're making challenges, you'll find that it's really hard to design something securely. It's even harder to design something to be insecure in a specific way. And through the course of giving this talk a few times, we found that there are some other ways that you can actually completely compromise the host that this application is running on. If you don't have Burp Suite and you want to follow along, grab it real quick. It's free. It's just a Java jar. Just Google Burp Suite, download the free version, pull it up. Yes, Portswigger. Portswigger is the company that built it. So let's start with something simple. I type a URL into my address bar in my browser, and I hit the enter key. What happens? First thing that happens. Anybody?
It's going to resolve the name.
What was that?
It's going to resolve the name.
Resolve the name. Resolve the name unless it's an IP address. Yes. So resolve the name. What does that mean?
It's going to contact the DNS server to try to get whatever URL you enter, these IP addresses for that.
Okay. So tell me what DNS is. Why does it exist?
It's hard to remember IP addresses. It'd be easier to remember google.com instead.
Basically, yes. Computers don't know where www.google.com is. That's not an address that they can route traffic to. So unfortunately, we're all humans. So remembering the IP addresses that are associated with google.com is kind of a pain. So what DNS does is it takes a domain name like www.google.com and it converts it to an IP address. There's all sorts of other crazy stuff that you can do with DNS, but for our purposes today, just know that DNS, when we hit enter, if we have a domain name in the URL, the first thing that's going to happen is our computer is going to issue a DNS request and figure out where the IP address is, or what the IP address is that is basically that domain name is pointing to. Okay, so we have the IP address associated with the domain, or in this case, we are entering in an actual IP address. So we know where we're supposed to be talking to. What none? And we'll go by hands. And if nobody raises their hands, I'll start picking people.
When we have an IP address, we send some kind of request there.
Send some kind? Absolutely, absolutely. What kind of request?
HTTP or HTTPS?
We're skipping one step there.
The handshake.
Handshake. What sort of handshake?
Right.
TCP/IP. Sure. Yes. So we establish a TCP connection to the remote service. So we're not going to dig into the details of TCP, but suffice it to say that now we have a tunnel that we can communicate, right, like a pseudo tunnel that we can communicate with the remote server across. So now our computer has established a connection to the remote server at the given port. What now?
We send in HTTP request.
An HTTP or HTTPS request. Yes, that is correct. So basically, if you've never dug into the actual HTTP protocol, there's a lot of kind of sloppy, messy looking stuff that's going on behind the scenes that brings you this beautiful screen. And that is what happens through HTTP requests. So let's take a quick look at what that actually looks like. So one thing that you should always keep in mind is that some of the best hacking tools are made for developers as developer tools. Case in point, this. So I'm going to reload this page. So we just saw a bunch of stuff happen here. Turns out that when I hit enter, multiple requests were sent. Why is that? No, go for it. Multiple resources getting loaded on the page, but I only requested one page. Why would there be multiple resources?
That's they depend on other resources.
What was that?
Do they, like, the page includes other resources and uses them?
The page includes other resources and uses them, absolutely. So in the HTML spec, there are various tags that have attributes that point to other resources that you need to request. So let's take a look at what that might actually look like. So we're going to come in here and we go to view page source. So when I submitted that HTTP request, and we'll look at what the actual body of the request looked like in a second, this is what the server responded with. This doesn't look very pretty. This isn't very nice. I don't really know what any of this means unless I know a lot about HTML. So we have a head tag, a meta tag, a title tag, link rel icon href equals images/favicon.gif. That href in this HTML is saying, hey, for the favicon, which is the icon that you'll see in the browser bar, go retrieve this image. That is a relative URL path to another resource that is currently held on that server. So basically what the browser does, sends the request, gets the response, and it parses that response. Now in that response, there are going to be various things that point to other resources that the browser then queues up for an additional request. That's why we're seeing, oh, come on, there we go. That's what we're seeing here. So in this original HTML response, there were actually references to a styles.css file, a css3.css file, jQuery, this other one, another styles file. So to reiterate, The browser got the HTML, it parsed the HTML, it found the other references that that HTML was linking to, and then it loaded those as well. So I should have asked this earlier. Quick show of hands, who actually has web application backgrounds, has done web development, anything like that? Okay, so about 50%. So in a lot of cases, it's going to be the case with this one. The way that a web server works, grossly oversimplifying things, is that it maps part of a file system to a web server, right? So on the web server side, when I request 192.168.126.130 / Coruscant photography / what the web server is doing is it's saying, hey, I'm configured to distribute content out of this directory, all right? So it's looking for a directory within that one entitled Coruscant photography. And if it finds that, it serves content from that directory. So when you're looking at the URL paths in URLs, the URL path being anything after the IP address or domain name, that's in a lot of cases mapping specifically to a file path on the web server, and it's giving you the file that's being requested. Does that make sense? Everybody following along so far? Cool. That's not always the case. There's lots of stuff if you've ever worked with Rails, if you've ever worked with Django, if you've ever worked with a number of various frameworks, it's not actually mapping a file system to the web server. It's actually just parsing. It's using these as variables that are being passed to the server and invoking some sort of functionality. As far as security is concerned, which one of those two might be better?
Probably the second.
Why?
Because if you're just mapping files on the file system, it's easy to like leak data.
That's right. That's absolutely right. And one of the things, so for anybody that didn't hear, one of the reasons that opting for the, we're actually mapping URL paths to specific functionality instead of just retrieving files from the disk is, what happens if you accidentally leave a file in one of the directories on the web server? What if there's executable code in that file? Maybe it's not linked to, maybe there's no links to it, but if it's sitting there and somebody finds it, what could possibly happen? No, but execute, huh?
You're giving free reign to whoever just made that request to basically an entire subsection of your hard drive.
Exactly, exactly. So it's, you will find, so Joe, same guy that authored this application that we're going to be looking at, he calls PHP an API for remote code execution, and I tend to agree with him because more often than not, developers will leave debugging scripts. They'll leave, maybe you're making some edit to the production web server, so you make a copy of the current file and name it .old, and then make your current edits, make the edits to the actual one that's on the server. Well, that .old file is still there. Not only that, but because it has a different file extension, you're actually leaking source code now. So going one step further, talking about how the web server works, these ones that are mapping file systems to what you can request through the web server. Can somebody tell me what happens once the request is received internally by the web server? What I'm looking for here is a comment on why file extensions matter.
Well, so it's looking at the file extension to see how to serve the file. So like, does it serve, I mean, I'm not too familiar with like web server, but I guess like if it's a .html, it's going to serve it as a web page. Yeah.
Right. So with these configurations that are mapping file systems to web servers, generally speaking, what you will see is, here's how the logic goes. First, it's going to see, does this directory exist? So if I requested Coruscant photography /foo/bar/bang, it's going to see, hey, does this directory actually exist? If it doesn't, 404. If it does, what's the file that's being requested within that directory? Now, right now, there's no file after Coruscant photography. So I'm just requesting a directory, apparently. Why then did I get HTML?
Because Chrome, or Firefox rather, knows to look for index.html or index.php?
Close. It's not Chrome or Firefox. It's actually the web server. So basically, when you request a directory, the web server is typically configured to say, hey, if they didn't request a file, here's the default file that they should be looking for. Then the default configuration with these servers is it's going to be, hey, if there's an index.html page in this directory, serve that. Or if it's PHP enabled, if there's an index.php file in this directory, serve that instead. Okay? So that's mostly how web servers will handle the request. Now that they know the file that you're requesting, what the web server is going to do next is look at the extension of that file. And what you can do in the web server is configure different file extensions to be handled by different things. .html, the logic for it is, oh, you requested an HTML file. Read this file and send it back to them. Don't do any additional processing. When you request a .php file, on the other hand, it's along the lines of read this file, take the file contents, send it to the PHP interpreter, have the PHP interpreter execute that file as PHP code, take the results of that execution, and send the results back, right? So when you basically different functionality can be invoked based on different file extensions. So going back to my comment before, when you took index.php and you renamed it to index.php.old, that's no longer getting passed to the PHP interpreter. If you've seen how PHP is written, we'll look at it in a bit. That means that all of the code that would have been executed to dynamically generate this page is not being executed. It's just being returned. So you're now seeing source code, which is why I say when you rename something and you forget about it, you have source code disclosure. Are there any questions so far? Good deal. So, like I said before, this is an application that is designed to be intentionally vulnerable, and we are going to hack into it. We can get a root shell on the system that this application is running on if we do the right things. I have no idea what this application does. I've never logged into it before. I've never seen it before. This is the first time that we're even touching it. What should I start doing? I saw a finger. Was that a yes? No? No? Okay. SQL injection. SQL injection. Okay, so I'm just going to throw SQL injection at this web page. In a submission box. Interesting. Okay, so I would need to find the submission box, right? Huh?
Find something that takes input, login pages, register.
Right.
Anything that posts.
Right. So what we want to know now, what we want to find out is where are all the places that I control data? This is not just for web applications. This is anything that you're interacting with. 9 times out of 10, when you're abusing a system like this, it's based on the developer wrote software expecting the input to be these things, but they also did not put any protections in place to restrict that input to only these things. So you can pass it input that is not expected. And depending on what's being done with that input, depending on the functionality behind the scenes, that can invoke functionality that it's not supposed to. That can read files that it's not supposed to. Maybe you can write to a file. If I was able to write to an arbitrary location on the file system where this web server is running, what could I do with that?
You could probably write your own PHP code and then execute it to execute it.
Right, exactly. So if I was to have something that seems fairly harmless, I'm able to write files to the disk. Okay, cool, maybe I'll fill up your disk, whatever. It's actually kind of worse. Because if I can write a file with a .php file extension, and I can put that file in one of the directories that is being served by this web server, that means that I can run arbitrary PHP code. Does that make sense? So we want to find input boxes. We want to find places that there's user interaction. How do you usually do that when you're talking about a website? Am I just going to click on everything? Huh? Login page, sure. But again, do I want to do this manually? Do I want to click on every single button? Maybe there's stuff in the HTML that is not even being rendered on the page. Maybe it's in a comment tag. Maybe it's commented out. So what is a method? Hey, there we go. So now we're going to start looking at Burp Suite. But before I open it up, can anybody tell me what an HTTP proxy is?
A proxy is basically like a middleman between you and the actual destination.
Right.
So the proxy would, or you would connect up to the proxy, and then the proxy would connect up to the.
Exactly. Exactly. So to reiterate what was said, when you send your HTTP request, if there's no proxy, you're literally just connecting to the remote server, and you're sending it the HTTP request and getting the response. When you configure a proxy, you're actually connecting to the proxy, telling the proxy, hey, this is who I'm trying to talk to, and this is what I'm trying to say. And the proxy will then submit that HTTP request. It will get the response, and it will feed the response back to you. So that's why Burp Suite is a proxy. The proxy doesn't have to be a remote server. It doesn't have to be anywhere else. We can have a proxy on our local machine. So when you're using Burp Suite, what you do is you configure Firefox to have Burp Suite as a proxy. So instead of sending the request straight to the web server, it's actually sending it to Burp Suite, and Burp Suite is then sending it out. Now, if Burp Suite is a man in the middle in this connection, think about all the crazy stuff that you can do with that. One of the other things that you will commonly see as an error on the behalf of front-end developers is they think, oh, well, you know, there's a drop-down here that only has these 3 values. Therefore, there's no way a user can submit any values other than the 3 in the drop-down.
Did they use Firebug for that?
Exactly. So Firebug is one way that you can do this, but HTTP, this is just HTML. This is just rendering. This is a browser. This is part of the actual whole HTTP HTML suite, but at the same time, you don't have to be interacting with the web server through a browser. You just have to be able to talk HTTP to it. And if you can talk HTTP to it, good. You can do all sorts of arbitrary stuff. So if nothing else, have one big takeaway for this meeting be, front-end security controls don't mean anything unless you're trying to protect your clients. All right? Unless you're trying to protect the browser of somebody that is using your site, front-end security controls do nothing for the security posture of your web application. So this is a pretty great little plugin that I use for Firefox called Foxy Proxy. It enables you to very quickly switch between various proxies that you're using. I have it configured here. You'll notice that the proxy is pointing to 127.0.0.1 on port 8080. That's because that's where my Burp Suite proxy listener is. Basically, when you fire up Burp Suite, it actually fires up a network service that you can communicate with, and that's your proxy. So I have it configured, and I'm going to load this one more time. There's a lot of stuff in Burp Suite. We're going to cover most of what you need to know. We won't cover everything, but we'll start over here in the Target tab. So as I've been talking and as these things have been loading, what Burp Suite has been doing is, it's man in the middling all of these connections, and it's keeping track of all of the requests and responses that have flown through it. In this first view that you see here in the Targets tab, we see every single endpoint that has actually been communicated with. So it's pretty crazy to see that by only loading two pages in Firefox, my browser has sent requests to, what is this, over 30 different domains, pulling various resources. But we care about this one. So here we can dig in to the web server on 192.168, and we see that there's this Coruscant photography directory. Now, a lot of this stuff is grayed out in there. The reason that it's grayed out is because basically a link to that resource has been observed in one of the responses, but it hasn't been requested yet. So now we'll do one of the most basic things that you can do in Burp Suite, which is crawl. So you right-click, and you hit spider this branch, and you add it to the scope. And now as this is running, it's going to prompt to say, hey, do you want me to submit these forms? Do whichever. Boom. Burp Suite just went and found every single link that it could across all of the HTML, across all the pages that it found, and it requested everything. It tried to find every single resource that it possibly could on this endpoint. And you'll notice there's quite a few there. So we have about, blog, create, index, login, portfolio, upload. Anytime you see the word upload, you should be happy.
How does it actually go out and find every single resource?
Oh man, so as an aside, I have my own company that I'm building where I have to write this functionality, and it's rather complicated. But suffice it to say that, you know, in the HTML spec, there's various tags, like an image tag, like an anchor tag, like a link tag, like we saw, that say, you know, they are specifically meant to reference other files. So what Burp Suite is doing is it's looking at all the HTML it's already seen, and it's looking at all the references that are pointing to other resources on this server, and then it's requesting that, and then parsing the response as well. And it does that until, okay, every single link that I can find, I've already requested.
Okay, but if there's no link to a file, then it's not going to find it.
Hey, that's a good point. Well, how would we do that though? Because this is a great question, and this is something that a lot of pen testers miss. And if you basically, whether or not it pays dividends, strongly depends on kind of how good your approach to doing this is. But do you know what the word for it is? So they call it content discovery. And this is a tool that will request arbitrary files on the web server, basically just brute force guessing random file names. The more complicated ones, like the one in Burp Suite, will actually take all the resources that it has seen and try appending various extensions to it, like .old, .back, .zip. It does, like, you know, if you've ever been editing a file in Vim and then you did an ls on the directory where the file is while Vim is still open, you'll see that there's a copy of that file with a tilde at the end because it's currently being edited. So maybe somebody's currently editing a file on the server, anything like that. I'm currently using the free version of Burp Suite, so it's going to be, it's actually not going to be in here, I don't think. Yeah. So Burp Suite comes with content discovery functionality. Generally speaking, you should first crawl a web server and then run content discovery. But you have to have the pro version to have that packaged in Burp Suite. There's other tools that will do it. One of them is called OWASP Dirbuster. Don't ever use that tool. Don't ever touch it. It needs to be burned with fire. I would recommend more strongly a tool called dirsearch. It's a little Python script. You can find it on GitHub. And instead of an E, it's a 3, because they're hackers. So you'd want to run content discovery. For today, we don't really need to do that. That's not something we need to do on this server. So we crawled there, but you know what? Let's also just kind of click around and see what's here. So we have a services page, we have a portfolio page, testimonials. Also, all of the text on this website is hilarious. Unfortunately, we're not going to be looking at very much of it. So you can get like read more, there's login. Anytime you see login, you always want to try. Yeah, no, admin. You know, I don't know how many of you guys have actually done work in the real world yet, but everybody's, oh man, admin, that probably never works. Nope, that works all the time. Unbelievable. So all this stuff, that's great. I'm going to come back over here to Burp Suite. So you notice that there's some different icons next to these files, right? So we have what looks like a folder, we have just some plain pages, and then we have these like gears, these gear icons. And what these gear icons represent is that this endpoint takes input, takes some amount of user input, whichever. And when you come over here and you click on one of these arrows, you can actually see various requests that have been submitted with different functionality in there. So we got a view.php, all this. And so we see that there's been 3 requests to view.php with different parameters. All right? Let's take a look at view.php. Who can tell me what that question mark up in the URL is?
It's a get parameter.
It's a get parameter. What is it called? What is that part of the URL called?
Query.
Query string, that's right. So one of the ways that you can submit data to a web application is through the query string. The query string is defined as anything that follows the URL path after a question mark. So when you see a question mark and a bunch of stuff after it, that's data that is probably being consumed by the web application and something is being done with it. Generally speaking, it follows the notion of you will see a key name. All right, well, you'll see a key followed by an equal sign, followed by a value. And then if there's more arguments that are being passed, there'll be an ampersand, and then another key equals value, ampersand, key equals value, so on and so forth. There's no real limit to how many arguments you can pass. I want to say there's a limit to the length of URLs that will be, there's definitely a limit to the length of URLs that will be processed, but I want to say that there's even a limit in the RFC to this is the maximum length that a URL will be. But anyways, so that's what's up there. One of the other things that you will see, especially in modern times in single page applications, is I found out that it's called a shebang. I usually call it hashtag, but a shebang followed by stuff. And this is another way that you can provide data to the application. However, anything that you see after that shebang is never submitted to the web server. It is only data that is being used and manipulated by the front-end client. So if we're trying to attack the server, any data that we see after a shebang is really not doing much. Again, it's never being submitted to the server. By default, we can put a shebang in here and type a bunch of stuff after it and look at the actual HTTP request, and you'll see that none of the data that we typed is included in the request. I realize that we haven't actually looked at what a GET request looks like yet. So when your computer sends a request, this is what it's actually sending, right here. So the first thing, it's a HTTP verb, which in this case is GET. There's a number of HTTP verbs. There's GET, POST, PUT, CONNECT, DELETE, TRACE, options. I know I'm for a patch. I know I'm forgetting some of them in there. But you have the verb followed by the URL path, including the query string, followed by the version of HTTP that's being queried, and then a number of HTTP request headers. These are automatically being populated by your browser every single time that you request them. Don't have to touch it. This is just all behind the scenes. In this case, none of this is very important, but one of the things that we don't see here that you'll see all the time is cookies will be populated here. So if you've ever heard of like cookie stealing attacks or don't disclose your cookies, it's because the content of those cookies is being submitted alongside the HTTP request, and those cookies, in a lot of cases, especially with session identifiers, are how the web server identifies, hey, who are you that's trying to talk to me? Are you authenticated? What privileges do you have? It's mapping your request to access controls and privileges on the server side. So this is it. This is all that's being sent. And in response, we have the first line, which is the HTTP version, followed by the status, followed by the status message. So HTTP 200 is great. Everything's cool. Here's your file. Followed by a number of headers, followed by two, I hate HTTP, followed by two carriage return line feeds, followed by the contents of the resource that are actually being served. So here we see the HTML that we just saw in the browser. But we didn't see when we were looking at the source were the response headers that came with it. So here we see the date, we have the server, we have x-powered by, and then these other ones you'll see in pretty much everything. The MIME type of the content that's being served, so on and so forth. Can anybody tell me, are there any issues up here? Was that like a half hand raise or a neck scratch? That was a neck scratch. All right. Yeah.
Well, you're telling what PHP version you're running as well as the OS version.
Yep. Why would you want to tell that to anybody? What benefit do you get from them knowing more about your application than they need to? This follows the principle of least privilege, which is kind of a core tenet of information security. You only give people what they need to do what you need them to do and nothing less. Here we can say, oh, Apache 2.4.7, it's running on Ubuntu, and the PHP version is 5.5.9 with this specific Ubuntu spec. Now, this particular version is not vulnerable to any publicly known exploits, but if it was, this would be all I would need to exploit it now, because I know exactly what version it is. Now I can go, that's one of the first things I do when I see a weird version is literally just copy paste that version and then put the word exploit after it in Google, and sometimes like Metasploit pops up. It's great. So that's an HTTP request and response. And with that being said, we're going to come back over here. So I was talking about the query string, talking about how this is one of the ways that you can supply data to a web server. The other way, there's a number of ways that you can do it, but query string is one of them. And when you're working with HTTP post requests, you're not going to see the data that you're submitting in the URL. Where will you see it? Well, what part of the request is it called? The post, it's called the request body. So for instance, I saw, let's see, is this a post? Yeah. So here we have another request that was submitted by Burp Suite. And this is an HTTP post request. You'll notice the verb right here says post. You'll also notice there's no query string. And lastly, you may have noticed that there's some stuff down here. This is how data is supplied to servers in a post request. That's not to say that when a response is or when a request is handled, that it's not going to take data from both the query string and the response body. But all of the other HTTP verbs that intend to put information, to give information to the server, you're going to see the data you're submitting in the request body. All right, now for the third time, I'm going to come back here, and now we're actually going to talk about it. So, query string. What's in the query string up there? I see article equals, and then a bunch of garbage. What is that? Unique identifier. OK, yeah, let's try that. So it's a unique identifier, which, you know, if that's a unique identifier, and there's a few pages that have unique identifiers that it's pulling from, then how would I verify that it's a unique identifier? Give me an idea for how to do that.
Click on different pages and see if the identifier changes.
So we know that there's different values in this field, so we know that that part changes. But if our hypothesis is this is a unique identifier, what would be, you know, apply the scientific method to this? We have a control. What is the experiment? You change it. So if it's a unique identifier, and it's had, you know, maybe on the server side, you know, let's think about, you know, you should always be doing this whenever you're doing any sort of assessment. Think about what the code is doing here. Well, I've got a parameter. It's named article, and it has a bunch of values. If our hypothesis is this is a unique identifier, what does that code look like? Oh, I'm going to take the unique identifier, I'm going to do a database query, and if a row matches, then I'm going to serve up content based on whatever that match is, right? So if that is our hypothesis, we could say, let's give it an identifier that, you know, doesn't exist. The page just changed. The page just changed, but there's nothing on it. So we changed what we thought may have been a unique identifier to an identifier that doesn't exist, and we didn't get anything from the page. So, OK, maybe it is a unique identifier. Who here knows about different formats of encoding?
If the text is encoded in some way, then it could seem like it's hashed, but in reality, you can decode it.
Could? Yes, yes, you could decode it. So can anybody tell me what base 64 encoding is?
It's a way of mapping sequences of bits to the alphabet, and the uppercase alphabet, the numbers, and punctuation.
Why?
Because 64 is the power of 2.
Almost, almost, yeah.
You can represent a lot of numbers in a string.
Actually, when you base 64 encode something, the string gets longer in most cases. Actually, I'm pretty sure all cases. Huh? Printable. Getting closer. The reason that base 64 was actually invented was because it encodes things into a sequence of characters that does not include anything that would be a control character. Now, a control character is a carriage return, is a line feed. It's something that is telling whoever is consuming it to do something. And the origins of base 64 were basically when networks were far less complicated than they are now. It was, oh, well, we need to transmit this data between two endpoints. But it turns out that that data actually has a control character, that they're intermediate hops Basically, when they're processing the data, instead of understanding that, hey, all of this data needs to be sent, it starts consuming that data, hits that control character, and it's like, oh, that's it, hops out. So by taking the data that you want to submit and encoding it in base64 encoding, you are able to pretty much guarantee that you're not going to run into one of those issues. That's at least the origin of base64 encoding. It's used for myriad things, but that's at least where it came from. So let's go back for a second. One of the ways, and this is something that the more you do this stuff, the more obvious it becomes, various kinds of encoding. They kind of like pop out to you once you get suitably familiar with them. So I see this and I immediately think like that's base64 encoded. One of the things that is a dead giveaway of base64 encoding is, I'll take this one. Another really cool feature of Burp Suite, when you right click on any request, you can just say copy URL. And then it automatically just copies the URL for you. It makes it really easy to hop between the two. So in this case, what's the last character that we see in that argument? Equal sign. If you ever see an equal sign or two equal signs at the end of what looks like a bunch of gobbledygook, that's pretty much guaranteed to be base64 encoded. That's just an artifact of the encoding scheme. If during the encoding process you hit a specific boundary, in some cases you don't get the equal signs. It's basically just an indication of padding for the algorithm. So with this is very obviously base64 encoding. So let's see another cool little piece of functionality that Burp Suite has. And it's called the decoder. Super simple. You paste whatever you want, and it has a number of different ways that you can decode or encode that data. So for our purposes, we're going to say decode to from base64. So what did it just decode to? If you can't read that, it's ep1.html. Somebody walk me through what they think might be going on here. Again, this is an argument supplied to the web server via query string. It's base64 encoded, and when we base64 decode it, it looks a lot like a file name.
So PHP is basically just requesting it, requesting this specifically based on what are the articles, correct?
Right. In the back, you had?
I was going to say it's assigning a specific value to the parameter article based on which one you click on.
Yes, that's on the front end. Yes. So let's put ourselves back in the developer's shoes. I'm a developer. I want to write a blog. I want to build a blog, and I want to make it so that people. Here we go.
It's reading f1.html on the server through whatever file is taking that parameter and it's spitting it out.
There we go. So that's some logic. That's some logic that sounds like an amateur web developer would build, where basically like, oh yeah, well, you know, we need to make it so that you can just write new blog posts as in HTML format, and then you just drop them in this folder, and then whenever you want to put a link to a new blog post, you just base64 encode the name of it, and then that's the link. You put it up there in the URL. What could possibly go wrong? Let's confirm our suspicions before we go any further. So we'll come back here, and we'll take this. Yet again, when we decode it, it decodes to what looks like a file name. Quick caveat in PHP. There's basically two different ways that you can read files in PHP. There's more than two functions that will do this, but one of them is, hey, just read the contents of this file and give them to me. The other is, hey, process the contents of this file as PHP and give me the results. Those are two very different things, because one of them is executing code. The other one, just reading file contents. So all of that being said, we've got this functionality. What can we do? What can we do here? Read files. Yeah, okay. So, yeah?
See if you can directory find
Yeah. So this is a vulnerability called directory traversal, where basically the intent of the web application is we're going to let you, we're going to let you specify a file for some form of functionality. Maybe it's like we let you download files, we let you do this, to do that, or the other thing. But directory traversal is where that input is not being correctly sanitized, and you can put various file paths in it. So if that's what this is doing, what's the next step? How do we verify if that's the case? Because keep in mind that the only, yeah.
Try to get that or versus track HTML from that directory.
From that directory, okay. Yeah, sure, let's try that. Nothing.
Try to read view.php.
Read view.php. Okay, so how would I do that?
Base 64 encode view.php and pass it as the article parameter.
Okay, let's try that. It doesn't look like it did anything. Let's double check. Oh, what's that? Oh man, stuff in comments. Yeah, this is why crawling programmatically beats crawling visually, because this is commented, meaning you are not going to see it in the browser. But if all you're doing is processing HTML, that doesn't matter. You can find this no problem. So it doesn't look like anything was placed into this HTML. So view.php did not work. What else can we do? Again, let's think about the scientific method here. We need to control for as many variables as we possibly can so that we can kind of isolate what's going on here. What are some reasons that could have failed? Keep in mind that when we requested that HTML file, we got a 404.
It's searching a different directory than just the horizontal.
Yeah, okay, so it's in a different directory. It's in a different directory. Do we know what directory it's in? No, we don't know what directory it's in. What happens when you request a directory on a web server? If I just request /Coruscant photography, what happens? We already talked about it. Gives you the index page. Okay. What can we do with that information?
Look through each of the everything that's on that next page.
Maybe. I would say that, all right, let's have a control. We know that there's an index.php file. Not only that, but of all the different files that we could possibly pick, it's the best bet because it is the most common file to find. We know it exists in the web root, we know that it exists, and it's probably going to be in other directories if there's other directories that are running PHP code. So let's go with index.php. That still, and you know what? I'm actually going to come over here because this will be easier. Still nothing. Okay. Where do we go from here?
What happens if you don't pass it, Mark?
Yeah, let's try that. Same. What if we give it weird characters? Same. Where do we go from here?
Could you try to move to a different directory?
Haha. Yes. So, web servers. Permissions on Linux file systems, on all file systems. I mean, if you lock this down correctly, the only files that the web server are going to be able to is going to be able to access are files within its web root and various log files, configuration files. So that means that those HTML files that are potentially being included here are somewhere in the web root. Maybe they're not in the root directory. Maybe they're in a subdirectory. Maybe they're in a subdirectory of that. But we know that they're at least in a subdirectory within the root directory that's being served by the web server. Yeah, does that make sense? So let's try this. Instead of requesting index.php, let's do .. index.php. Oh, that's different. So what does this tell you?
We're in a directory we're in a directory whose parent directory has it.
Yes, yes. And in this case, basically those HTML files are within a subdirectory from the web root. So it's one directory deeper than the web root. So we went ahead and said, you know what, instead of that HTML file, load .. index.php, and then we got this. Cool, cool. What was I saying before about file reads?
They're either read or executed.
Read or executed. So what do you think we should figure out now?
Are they executed?
Oh, they're executing files. Exactly. How do we do that? Not quite.
Can we just start typing like shell command?
I wish it was that easy. Lots of times it is that easy, but not in this case. We want to be able to, again, scientific method. We want to be able to control for something. What's the difference between the execution and the file reading? If we take one file with PHP and HTML in it, and we execute it with the PHP interpreter and take the results, and we just take the file content, what's the difference between those two files?
The extension.
Extension, not quite. What is going to be different about the content of those two files? Maybe I need to actually show you what PHP does. So this is how PHP works. If I was to pass this file to a PHP interpreter, what it starts doing is it starts reading the file byte by byte. If it's not in PHP mode, if it's not in I'm currently executing code mode, it just spits out the bytes. So what this is going to do is it's going to start reading through the file and start spitting out hello world. Now, that stops as soon as you get to an open PHP tag, which is what you see here. When you hit that open PHP tag, the interpreter switches from, oh, I'm just reading bytes out, to now interpret whatever is coming in as PHP code and execute it. And then any of the results that are returned by that code, embed them in the page. It continues to operate in that mode until you hit the close PHP tag, at which point it returns to just spitting out content. So what would the difference in this file be if I passed it to the PHP interpreter or if I just read it like this?
If you pass it to the interpreter, it'll give you the PHP code.
Yes. Yes. Right. And back there, yeah?
Is it possible to have an open PHP tag literally encoded as just a read file?
Is it possible to have a PHP?
I mean, like if you were just searching for the open PHP angle bracket question mark PHP, does that only exist in files that?
Well, we'll put it this way. They certainly won't exist in files that have been executed. Because again, they won't exist in files that have been executed. So if whatever the response returned by the server looks like contains any PHP code, that indicates that it was not executed. If it doesn't contain any PHP code, that indicates one of two things. Either there is no PHP code in that file, or there is PHP code in that file and it was executed.
Index.php has PHP code.
It definitely has PHP code. So we're going to come back here and view the page source. Hey, look at that. That's source code. So this is a file read. That's somewhat disappointing because if it's a file execute, this is usually, so one of the really cool things that you can do, one of the great ways to pop these is the web server is automatically going to have, well, in the vast majority of cases, going to have read access to the log files that it's generating. One of the things that it logs is the user agent of whoever is communicating with it. The user agent is one of the request headers that is automatically populated by the browser that contains information about what this browser is. Is it a mobile browser? Is it a Mac browser? Whatever. That's data that you control. So if I control my user agent and there's a log file readable by the web server that's automatically writing my user agent into it, I can just set my user agent to executable PHP code and then include the log file. And because of the way that PHP works, it'll see the PHP open tag, execute the code that I want it to, and then spit out the rest of the log file to me. So that's a really cool way to do it. That's a lot of fun. This is not that. So we have file reads. We can read arbitrary files, whatever. I mean, that's cool, but I'm not super psyched about it yet. But let's go back to what we saw before. I guess I can even have it right here. So this says admin only, and it's an upload page. File uploads, super difficult to get right. Very, very easy to get wrong. And if you get it wrong, if I can upload arbitrary files to your web server, that's bad news. This is admin only though. And because we're you know, for the sake of time, we want to have access to this upload functionality. Not only that, but in order to do that, we need to be an administrative user. So let's go back here, and I'll skip ahead a bit. So I'll come to login, and I'll create an account. Sweet. All right, so create an account, and now I'm going to log in with this account. All right, so I am successfully logged in now. Let's take a look at what those requests actually did. So here we have the login request. This is the HTTP post request that resulted in me logging in. Now, because I knew the correct username and password, I authenticated successfully. And because I authenticated successfully, now the web server wants to be able to say, okay, now when you continue to communicate with me, I know who you are. I can assign a user identity to you. In order for it to do that, it sets a cookie in your browser. We see that in one of the response headers here. It says set cookie, UID, and then this number right here. Now, if anybody else knows that number, they can now impersonate me. This is how the server knows who you are, which is why, you know, if you've ever opened up developer tools while you're browsing Facebook, if you haven't, do it right now. It's pretty funny. It's a big message in big red bold letters saying, do not type anything into this box. People will hack your account. Because that's one way that you can very easily access the contents of the cookies that you currently have in your Facebook session. So if anybody knows that value, that is bad. They can log in as me. So what does that mean if I want to authenticate as an admin? If I knew that value for the administrative user, then I could very well impersonate the administrative user.
Why don't you just go back to how you're reading PHP and read the login and upload?
Read the login and upload pages. What would that do for me?
Well, it would let you know how the server takes your fields.
Absolutely, absolutely. So now that we have a file read, we want to start looking into what this source code does. Again, if we have the user ID, or if we have this UID value for the administrative user, then fantastic, we are authenticated as that user. So I'm going to come back over here, and because we know when we do .. we're in the web root, then we know that all of these other files we can pull down. So let's check out login.php. Hey, check it out. So So this is the code that is being executed whenever you try logging in. So let's read through this code real quick. So these require once function calls are what I was saying before. When you pass a file path into require once, include, or include once, that is saying, hey, take this file, pass it to the PHP interpreter, execute it, and take all of that code and put it in the current context. So I now have access to all the functions that are defined in that file, all the content of that file. It's all now in the things that I care about. So it's doing a few requires to include /config.php. In the interest of time, we're not going to grab that, but always pull config files. This one has credentials in it. This one has credentials to the database in it. That doesn't do us any good because the database is bound on a local port, so we can't access it. But password reuse is a huge problem. Anytime that you get credentials, you should use those credentials everywhere that you possibly can to see if they work for anything. But we're going to skip that config file. Require once include /common.php. That's probably functionality that is common across various pages. So we got this write head, create page header, start container, and then if is set username and password, authenticate user, username, password. And then if it's authenticated, do this. Name equals get username by UID, cookie UID, already logged in, blah, 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 blah. And then we have some other functions down here. We actually have the authenticate user function. So reading through it, we have it's connecting to a database. If it can't connect, it dies with an error. It selects a database. It does some sanitization on the input that's being passed with that MySQL real escape string, which, so funny note about PHP. There's MySQL real escape string and there's MySQL escape string. This is a great indication of how terrible PHP is. You should only be using MySQL real escape string because the MySQL escape string is insecure. But it's still there, I think. I think it's still there in PHP versions. So then it's generating a query and then performing the query on the database and then retrieving the results. And then if there are results, it's setting a cookie. Ooh, OK. So not only is it setting a cookie, but it's setting the cookie that we care about. And it's setting it to this UID value. This UID value is being populated from what is returned by the database, which is to say that this value exists in the database. So what should we do then? Try reading the database. That is the method that was not intended that you can do this through. Is that depending on how the database is structured, depending if it's local, there are particular settings or particular setups with MySQL where you can just read the database file and a lot of it is just binary data, but any of the strings, any of the varchars that are in there, it will just pop out. So we can read the database to get this, but we're going to take the detour. We're going to take the scenic route on this one. I mean, it's like generating a SQL query here through string concatenation.
But you can't really do a SQL injection because he said it's using the escape string, right?
Yes, awesome. I was hoping somebody was going to fall for that. Yeah, so this would be SQL injection if they did not have this MySQL real escape string wherever it is. That's basically taking out all of the potentially bad characters from the string that was supplied by the user and then generating a SQL command.
Since we already know the database credentials and we know that there is such a thing as upload.php, can we do something with that?
We're still missing part of that chain. Still missing part of that chain. Getting there though. So the user ID value is in the database. We created an account. That account clearly generated that value because when we logged in, it was set as our cookie. Where should we look now?
Should we try and find the UID generator?
Where you register when you use it.
Yeah, exactly. How is that value made? How is that value made? If we know how that value is made, can we make it ourselves? So let's try that. I believe that's in create.php. Yes. Hey. Check that out. Right here, attempt create user. Attempt create user. Okay, is that function here? Ah, okay. So here's the code that is being run when we create a user. Let's run through what it does. Seed equals get seed, creates a connection. If it doesn't connect, it dies. Selects the database. srand intval seed, UID equals rand. Is there any problem with that?
If we can get the seed, we can get.
What is this doing? Tell me what this is doing.
So it's okay. So it's seeding the random number from the username, right?
Right. So to reiterate, when you're creating an account, it's taking the username that you're signing up with, it's passing it to this getSeed function, and whatever value is being returned by this getSeed function, it is seeding the random number generator that PHP is using. If you don't know what that means, basically random number generators are not actually random. In most cases, they're not even pseudo-random, cryptographically speaking. They're actually just like kind of random. And if I have two entirely separate instances on separate computers of PHP, and I seed the random number generators on both of them with the exact same value, and then get the next random value, they'll be the same. So if you know the seed value for a random number generator, that means that it's not actually random. So the only thing left now is, well, what is that seed? There's no function here. Where's the function?
Is it in another PHP file?
Is it in another PHP file? Which PHP file should we look in?
Do they show PHP and corresponding changes?
You mean these? Common.php. There we go. Let's see what's in the content of common.php. And now remember, it's in include/common.php. When we're doing this directory traversal, we're currently in the root directory. So we need to add the include directory. This is the same one. I'll come back over here. Aha, sure enough, there's our getSeed value, our getSeed function. Now, we could spend some time figuring out what this does. We could do that. We could write our own version. What I really like doing is stealing the code. So I'm going to take this code, come back over here, and we're going to create our own little PHP file. Actually, let's see. I'll do it in Vim. Okay, so now we have taken their function. So let's take a look back at what the code looks like. Not the code. Where is it? Here we go. So this was the attempt create user. Okay, attempt create user. So first it's calling this. And what do you think the admin's username is? Oh, okay. Okay, so it's setting that seed. It's getting that seed. And then it's calling this. And then it's setting the UID to this value. Okay, so if you don't know PHP syntax, don't worry about it. This is basically, we've stolen their function. We're reproducing the same stuff that they're doing in their application. We're just doing it on our own. Hey, that looks very similar to that UID. So we're going to come back here. Already logged in as test1. We're going to come here to the console. Now, whenever JavaScript is accessing cookies, it's stored here. So I'm just going to set that value. Make sure that it was set. OK. And I'm going to reload the page. Oh, check that out. We are logged in as admin. Not only that, but it looks like there's another page up here that I can barely click on. OK. Haha, and it's uploading pictures. Now, I know we're running short on time here. So generally speaking, file uploads are a terrible idea. I try to avoid them as much as possible. If you are uploading files using using a file server that's not even on the web server, doing strong input validation, like it is really, really difficult to validate file contents. One way that you can address this without much headache is using something like Amazon S3, where it's just a file store that you can store arbitrary data on, and then even if it's bad data, it's not something that currently exists on your web server. But we're going to do another, let's see. So this is just a quick and dirty, you should never do this. This is Script Kiddie 101. If you do this, you'll get caught immediately. Like there's plenty of other really cool stealthy ways to embed PHP code in what you're doing. But what this is doing is basically saying, hey, take the query string parameter C, pass it to shell exec, which is just, hey, execute this in bash, and then echo the results. So, and I don't know where, I'm gonna have to unplug this real quick. All right. All right. So I have selected that, and we're going to say the picture name is shell.php as well. And then we're going to hit upload. Picture uploaded completed. What's great about this is you can actually see that they're not even checking the content type that is automatically filled out in the request. When you upload a file, there's something called MIME, which depicts like this is the type of content in this file. And if it's an image file, it'll be like image/PNG or image/JPEG. This is just text/PHP. If you really want to be able to check like that, it's also you can modify it, you can make it arbitrary things, but even the lowest level of security checks against this sort of stuff should be checking the MIME type. So we uploaded that file, and in the interest of time, I know where it is. It's right here. Okay, so this is the file that we just uploaded, and remember, we said basically take the C query string parameter, take the contents of it, execute it, and show me the results. And there we go. And it's even nice and formatted if you look at it in source. So we have the ability to execute arbitrary commands on this machine now. One of the things you should always do, check out who am I. That's the user you're currently running as. Unfortunately, this is www data. If we had more time, we could take this and then do like Linux exploitation and escalate privileges up to root, but we don't have enough time. That's for another session. So yeah, we just went from never having seen this before, never having touched Burp Suite before, to find injection points, test them out, see if anything sticks, file a directory traversal, reading source code, figuring out how stuff works, using that to bypass authentication functionality, uploading a file, and having that file contain executable PHP code. And that's how this works every single time. That's honestly more complicated than it is in a lot of cases. And then lastly, I know that I said that I would leave you guys with some places that you can do this and not get in trouble. My #1 recommendation for you is to check out this website. This website. Don't hack lawn. That's not at all what I meant.
Don't get caught hacking lawn.
No. Who said that? Who said that? Don't hack lawn. And that's not even funny. Okay.
I'm sorry.
That's okay. I get comments like that all the time, but I am dead serious. If you do this, I know exactly who's going to catch you, and he is going to have no mercy. And that's Keith. There was one time when I was president that one of our members posted some stuff on our bulletin boards because we threw them all up in like a short amount of time, and it was vulnerable to cross-site scripting. Keith went on a rampage. He found the dorm that this person was in. He found the IP address that they were coming from, and he was about to go knock on the door and figure out who they were. And I was like, oh no, that's one of our members. They were just demonstrating that, you know, we need to fix some things. So seriously, don't do it. This is called VulnHub. What VulnHub is a repository of images of software that is made specifically to be vulnerable in specific ways. There are a ton of awesome web application images here. All you got to do, get VMware or get VirtualBox, pull down an ISO, install it, and then get going. It's on your local machine. You're not messing with anybody else. You're good to go. That is a great way to cut your teeth here. You want to take it one step further? And a good friend of mine, if you get good at this, you can make a lot of money doing it. When I say good at this, you have to be like top 1% or better, because he's probably one of the best in the world. But HackerOne is great. This is a site that kind of manages bug bounty programs. And what a bug bounty program is when a company says, look, yes, you are allowed to hack us. If you follow these rules, these are the things that you're allowed to attack. These are the things that you aren't. This is how you disclose to us. You don't tell anybody else, responsible disclosure, and if you do that, we reward you. Sometimes it's with shirts, sometimes it's with swag, sometimes it's with money. The guy that I know has made over half of the last full-time salary that I had in 6 months doing this. That's in addition to his full-time job. So this is a great way to do it, and this is actually, you will be breaking into real companies. Like, there are hundreds and hundreds and hundreds of companies that have bug bounty programs on here. So check this out, check out VulnHub, and be responsible with this stuff. And I'll leave it there.